All right. Okay. Um, Greetings. So we've got a lot. We've got a lot today. So we're gonna talk about all of the glorious things that make Java glorious. We're gonna talk about encapsulation versus abstraction, polymorphism versus composition, and a lot. It's very wordy, but fortunately the English definitions we can lean on, and I'll explain that a bit later. We'll go over interfaces. Um, I'll show you an example of animal, mammal, cats, dogs, fishes, humans, whatever interface examples, and then we'll look at sort of a fusion of all of. We'll then build a fusion of all of the concepts above using like a point, line, circle, sphere example. Okie dokie. So, yeah. Everything's good in Jeffland, I assume. Let's see.
Yes.
All right, his server's up, his website's up, and you're good. You've looked at assignment 7 or started working on it or finished it.
Yeah, I finished it.
Yes, no, maybe so.
Oh, yes, I said I finished it. Sorry.
Oh, sorry. Okay.
Is my mic working?
Yeah, it's working now, but I didn't.
Okay.
Yes, initially. Okay, cool. All right, and then besides what we were covering, was there any requests?
No, not right now. Thanks.
Okay, just let me know.
Okay.
All right. So you might have to move that out of the way. Okay, cool. So encapsulation is essentially where a class has other parts. So when we're using like primitive types, that's it. Like the primitive type is that one type and it stores the one thing that it stores. But the concept of encapsulation is that a class could store or should be storing other things. It could have lots of variables, and it's encapsulating those variables, and it's wrapping those variables and calling it itself, and all those variables are important parts of it. So we've done that a lot in this class. We've done a lot of encapsulation. Every time we write a class, we're doing encapsulation. That's just the word for a class that has other parts. As opposed to just an empty class would not be encapsulation. But then abstraction is the concept which we've also done, which it doesn't necessarily reveal how it's coded. So when you make a setter and a getter for a class, it's the person doesn't need to know who's using your class if you've actually if there's a variable called that thing. So when you say get time, for example, you might be storing as a private part of your class time in seconds, and that's it. That's the only private part that you have. And when they say like get the current hour, your getter method is then going and dividing those seconds by 60 and by 60 again to give them that hour. But they don't need to know that. So abstraction is that concept that how the class is coded isn't going to be revealed in just the use of it. And that's important because that allows you to also change how your class is coded while keeping the front end, all of the public stuff, named the same. As long as the sort of the prototypes, the what a function or what a method is called and the kind of thing that it's going to return, people won't notice when you do a major refactor, when you change a ton of code. And so that's really important, and that's what makes Java's abstraction really powerful, is that you can go in and entirely redo sort of the back end, the behind the scenes of your code, but the people who are using your class in the first place are unaffected. They go, whoa, your code, the program runs much faster. but that they never needed to make any changes. And so that's really important. Okie dokie. Yeah, so encapsulation is just like in English where it contains other things, and abstraction is that the way, in the sense of the vagueness, where the um, the meaning the meaning of how something, the relationship between the public facing stuff and the private stuff isn't doesn't have to be forcibly defined. Okie dokie. And then polymorphism and composition. So polymorphism is essentially like the parent-child relationship. It's just that it can take many forms, and that children have everything that a parent has, and hopefully more. You rarely see instances of polymorphism where the child only has the parent stuff. And in those cases, you tend to see things where it's what's called overwritten or overloaded, where the child might have the same name of a method, but it does something a little bit different, or it does something that makes more sense in the context of the child instead of the parent. And then composition is it's essentially when a class has one or another class. So that's very, very close to that encapsulation, right? And it's a form of encapsulation where a class has other parts. So composition is specifically where a class is composed of other classes. And that's a little bit different than the polymorphism, because strictly a child, in this case, only has the one parent. But composition could be that a class has multiple parts of it. So like a line has 2 points or it could have 2 points. And so it's composed of a line is composed of 2 points. And again, that can be very much hidden with abstraction. So somebody may not even know that a line has 2 points. They may be using the line class in a way that doesn't reveal that. Okie dokie. So those are those 4, and hopefully the English meanings reveal a bit about what's going on. So now let's talk about interfaces. Jeff talked about interfaces a good deal on Monday, but it's really, really useful and incredibly powerful, because it's an agreement. It's a promise. Just like we do prototypes with our methods, that we're saying, hey, later if somebody is using us, later we're going to have a definition for this part. And so we can think of it as an is-a relationship. So, we're thinking of it as like a prototype or a promise that this class is going to have these parts. But if we were explaining it to somebody that doesn't know programming, we might explain that, hey, this fish is an animal, and this dog is a mammal, and mammals also happen to be animals. So you can actually extend an interface. So everything that this has, but not necessarily the other way around. The thing though is that everything that you have in your interface has to be defined. You can't just leave things blank. So if an animal has a method, then whatever interfaces that method, or whatever interfaces that uses that interface, has to have that method. You can't pick and choose. It's essentially, when you say that you're going to use an interface, you're promising that you're going to have those parts. So let's look at an example. So here's 2 interfaces. We have our base animal, and it's going to return an array list of type strings, and it's called diet. So here we could put in lots of strings of the things that whatever that animal eats. And then we have a territory which returns of type double. So that would be, you know, what the animal's territory is, how big of a territory does it have. And maybe maybe a particular animal doesn't move at all. There's like sea anemones where they don't move at all. So this is just going to return 0, right? Or if it's something that's very, very tiny that doesn't really ever move much, we're going to use a very, very small number. Okay, but then mammal here extends animal, and so it's gonna have everything. This is that parent-child relationship, but in the sense of interfaces. So you can do the same thing with classes. You can extend a class with another one, and that's the example of the polymorphism of this parent-child relationship. And so you can do the same thing with an interface. You can have a parent-child relationship with an interface, and so this this interface mammal means that if somebody's using this interface, not only do they have to have a milk yield method, but they also have to have a diet and a territory. Okay. Hopefully you can see this side. The Zoom stuff is in the way.
Yes.
Okay. So then we make like a fish, and we are going to implement animal, which means that the fish has to have everything that this has. So it has to have a definition for diet and a definition for territory. And it could have lots of other private things. I was sort of running out of space on this slide, but it has diet, and it's going to return an array list of that contains pellets and algae. So when somebody asks, "Hey fish, what's your diet?" It gets this array list of pellets and algae, and if somebody says, you know, territory, it's going to return this number. Then for this class, the human class, we would have to do exactly the same thing. We would need to have our diet, which, you know, we might say just, you know, meat and plant, or something like that. Or if there was a specific instance of a human class, we would have these as private. Instead of these being, you know, statically set, we might have a private part as part of the human. So if a human's a vegetarian, that they could go in and set this diet array list that gets returned. But that's us using this abstraction, that how the class is coded, it isn't necessarily revealed. So in this case, right, it's statically set. A fish will always return pellets and algae as its diet right now, but that we could very easily later on have this as this array list as some other structure. It could be an array list that's a private part of the class, or it could even be some kind of other list structure, or it could go out and fetch something from a website and then return that as an array list. We don't know, and it doesn't necessarily matter for somebody who's using this fish class, and that's the beauty of it. So yeah, so in the human is implementing mammal, which means that we have to have all three of these things, and then we're going to have the diet and territory. I omitted that, and then we have this milk yield, which returns, you know, just the number 2. I think that's 2 ounces or something. And there we go. That's how I do use interfaces. Any questions about interfaces?
Yes. So can I think of it as like an outline, and then when you use it, you can make it more to whatever is like more specific to what you're working with?
Yeah, exactly. Yeah, this is an outline. It could be thought of as a skeleton.
Yes.
People use that word a lot, skeleton, where this is defining the parts that a class is going to have. Or sorry, it's doing a prototype of all the parts that it's going to have, and then it this also forces us to do the definition. So an outline is good in the sense that it's saying all the parts that this is going to have. But one of the things that we can't do is that we can't write something like, hey, this might have this. This has to have this.
Oh, okay.
Yeah.
Okay. Thank you.
Yeah. Okay. So that's interfaces. And it's a lot. I mean, this can be absolutely overwhelming, but if we just take in the idea just like this, that that an interface can have a parent-child relationship, as well as classes, and that this is just, yeah, like a skeleton or an outline of what we would want if a class implements this this interface, then that means that it's going to have those parts. All right. I want to do this yet. Do I want to talk about? Yeah. Okay. So, we had talked about composition, and so this is an example where we might have a class that is, oh, and I should make these all uppercase now, so that a point class, that a line class could have two instances of a point class. So there's composition happening there, but that all of these could have an implementation of a shape. And so all of these, for example, we might, well, yeah, so let's just start coding that up. So Jeff. Okay, so let's pasta in our starter code. Okay, so we called it shape. Actually, do we want to do? Let's make another directory. This is going to get messy, so okay. Oh, sorry, new keyboard. Okay, so we're going to make some stuff. So let's make an interface called shape, and we're going to make a point class. And then we're going to make a line class. Okay, and then we'll make the others as we come up on them. So okie dokie. So let's make the shape interface first. So very much like how we do stuff here, it's just going to be interface, the name of it, and then what parts it's going to have. So interface, and then we're going to call it shape. And this is essentially the things that we want all of our shapes to be able to have. So we might have something like you want a two-string? Sure, we'll have a two-string, and this is going to be public, and then it's going to return a type string. And in Java, it is uppercase. We might have then also a print. And I don't know, any other things that you can think of that a shape might that one of these shapes might have?
Uh, Maybe how many dots connect to make the shape?
Okay, so number of points,
Sure.
because like it might be a point, it might be 1 point,
Oh, okay.
right? So like a point, a line, and then I don't know, for circle and sphere, what would we return?
So maybe that one wouldn't work for all of them.
I mean, maybe we have. I mean, for circle we say 360, and then for um, sphere we what is it? We just multiply 360 and 360, and then cylinder we you could multiply the height and then 360 for I don't know, is that or
Or we can keep it as how you have now.
okay. Yeah, I mean, I'm sure that there's lots of other things that I'm totally brain farting on, but
Yeah, me
um,
too.
the idea being is that you could add um, you could add things here, and then that's gonna essentially say that everything's gonna have these parts. So I'm gonna copy these guys and throw them.
Are methods in a interface always public? Do
Um,
they, do they have any private methods?
you could make private things. Um,
Okay.
yeah, I mean, yeah, they could definitely be private, but it's the interface more is I think that it's more keyed towards the public facing stuff.
Mhm.
Because because otherwise, if you have a private um, method that's in an interface, you're forcing whoever's programming to then use this internal part that's only used inside of their class.
Okay.
Um, versus the interface, the word interface is sort of the part that you're working with. So like your keyboard on your computer is your interface. And so if you were to make, and that's public facing, that you can see the keyboard and you can interact with it, versus how the key presses are being interpreted, that's private and that's hidden. But if somebody forced you to have your method be private for how you're doing your internal workings, then they're stuck with that name for that method. And what they might do, like if that happened, like if I was forced to use an interface where there was a private part, I might just like put a semicolon in it and then just like ignore it. Like make the method, but then don't have it do anything useful. Um,
Okay.
there are examples of interfaces that have private methods that are used for working with device drivers. So like I have a launch pad. You know those like musical DJ things that you press the button and
Yes.
it makes sound. So yeah, I
Uh-huh.
have one. I have one of those, and I wrote a ton of code in Java to make it do really cool things. Um, and it has interfaces that have private parts that are for converting things and interpreting things in MIDI, um, and that's just yeah. It really sucks. It's like not easy to work with because they're private parts and they're forcing me to name certain things to make them work. Um, Yeah, so it does there are interfaces that do have private parts, but it's not pretty.
Okay.
Okay, so cool. So we've got that interface. So now let's do our point, and we're gonna pause to our starter code because I am lazy. Oh, and actually, yeah, you know what's great? I could have just okay. So this is going to be point, and it's going to implement. I don't trust myself to type. And it's going to implement shape. Okay, so that means that we have to have these guys defined. And so we might have, now let's make two doubles. So we have our X and our Y. And so the toString, so let's just remember, is it in the integer class or? So I'm trying to remember if we have, if I have, yeah, integer. Hello. Am I not remembering how to spell integer? Integer dot toString, and then 5. Okay, cool. So I just had to remember what this was called. Okay. J shell is useful like that. So here we're going to say the toString is going to be just defined as, and we could do a ton of string concatenation. I don't know, in this context, do we want to do a formatted string? Let's just test this out. So if I say, I want to make sure that the concept of what I'm doing is going to work properly. So if we say like X colon plus Y colon, yeah. So essentially this is what we're going to be doing. So this idea here. Return so the J shell is really useful for prototyping and making sure things are doing what you want them to do before you commit to them. Okay. All right. Oh, whoops. There. Okay. So something like that for your toString. And we'll need our constructor, of course. We need our public point. So our default is going to just set them to 0. Then maybe we have and so we could, this is one of those instances where if we made this just X, we would say something like this dot X equals X. But I don't know. I don't like doing that. So I stick like a new or something in front. But keep in mind, new is a reserved keyword. So you want to make sure that there's no spaces there. Okay, there we go. So there's our constructors, our default and our overloaded constructor. There's our toString. And then for our print, we could literally just say system.out.println. If we're feeling really lazy, we can just call our own toString. You probably would be better off using a printf. It would be much more efficient. But in this context, this code works. So, yeah. Any questions about the point class?
No.
Okay, cool. Oh, did that get saved? Okay. So now let's make our line class. And this is going to be a case of composition. We're going to have 2 points in a line. So we're going to, yeah, so let's do that. And actually, let's open okay. All right. Okay, so we are going to make our public class, and then this is the line class, and we're going to implement shape. And this case, we're going to have 2 points, P1 and P2. And then we're going to have our constructors. So line, and here we're just gonna say P1 equals new point, P2 equals new point. Okay, and then we'll do the overloaded in a moment. So what we definitely need is we definitely need the toString, and we need the print. So in this context, what we can do is for the toString, if we're feeling super duper lazy, which as programmers should always feel that way, we should return like something like P1 colon and then plus, and we can say P1 dot toString. Now we're sort of revealing our innards, but I think that's fine in this context. And then P2. And, oh, whoops, I need friends. And so it's really nice because we don't actually need to know, we don't need to actually be looking at this code. If we were just looking at the interface for shape, we would know that we could do this. And that's one of those that's the nifty part about interfaces, is that we have this guarantee that there's going to be a toString and a print in point and anything else that we might be using, because we both use the same interface. Okay, right, so we're going to say P2.toString, and we could have something like public, actually could even be private, doesn't matter, get length. How do you spell length? Is there a G in there?
Yeah, there's a G in front of the T.
Okay, there we go. So, and we're going to just say that it returns type double, and right now we'll just return some number. We'll say the number 1, and then we'll add a to do. Okay. All right. So there's my to-do for myself to do the math, because I hadn't done it. So here we could also add into our into what we're printing out, or what we're returning. Oops, this one here. Plus we could say comma length, and then plus, and this is a double, so we're going to need to use the we're going to need to use the double toString. Okay. And let me just keep making this longer. Okay. All right. We might break this up. Let's break this up. Okay, something like that. Okay, and then again, we could just call our own toString for our print. And we have not checked to see if any of our stuff compiles yet, so let's do that. Oh, whoops, I have an extra semicolon. And I also, this is not right. That needs to be like that and like that. Okay. All right, so that's point. Let's do that for line as well, because I made the same exact mistake. All right, and then cool. Let's try that again. Ah, yes, that is in point. So let's go back to point. All right. And what is it about? Lossy conversion, double to int. Oh, did I make X and Y doubles? Ah, yes, I did.
Yes.
Ah, okay. So let's go fix that. So we need to use the double toStrings. All right. Okay. All right, compiles must be good, right?
Yay.
Yay. Okay. Yeah. Ultimately, when you're actually coding, you should probably every time you even make a blank class, a lot of times what I'll do is that even for the toString, I'll just return an empty string and then make sure that that compiles and then slowly build on that. But yeah, so when I'm actually coding, as opposed to just sitting here and doing an example, I know it's a terrible excuse that I'm saying, but yeah, get the skeleton working first. Make sure that even just returning generic stuff. A lot of times people run into errors where they just dive in, they'll code the entire assignment, and then they'll see if it compiles. And then they spend like days trying to figure out why something's not working. And it happens to be that, oh, they add an extra curly boy right here, and that would be it. Like they would be like adding, deleting curly braces, all the way over here. Yeah, and that might be on a separate page, right? They might have written several pages of code and then missing a curly brace somewhere. So having this sort of framework where you can look at everything, where it's still small enough to be able to see that is useful. And then we essentially just keep going along that same thing to make our circle and our sphere, is that we just keep going.
Kind of quick question.
Yeah.
In the other, yes, the line implement shape, does it have access, or were you able to do point P1 comma P2 because it's saved in the same place as the point.java?
Yeah, exactly. Anything,
Okay.
any classes that are in the same folder are going to be able to access each other and use each other.
Okay.
Just like we use other classes, like when we make a string or something like that. It's the same. It's the same way that we create it. And later, like not at Cabrillo, but later you will you'll have projects or what's called packages, where the code might be in a separate location. It might not be in the same directory, but it's sort of globbed together. And you'll see that a lot at like in companies where you will be working on code that's living in one folder and somebody will be working on code that's in another folder, but they're all part of the same project package. And so you can use each other just the same way that we use this point line example. And this is how Jeff's robot works. Is that Jeff's robot essentially grabs your code, copies it into the same directory that is where the robot is, and then it has its own main, and it has its own, it has its own other class that it then loads in your class just like this, and then it runs and uses your class for the various things and sees if it got what it expected.
Oh, okay. That's cool.
Yeah. But yeah, essentially, that's that. And I mean, we can keep going, but the idea being is that these all use the same interface, and they all will then also contain, like the circle would contain a line and a point. So in this case, this would have both a circle. It would have 3 points, right? Because it would have a line which has 2 points, and it would have 1 point which is the center. And that the sphere doesn't necessarily have to have any more than a line and a point, but that because a sphere still has the same radius and it still has that same center point, but that a sphere has different attributes of a circle. So there might be a circle might be get area versus a sphere might have a get volume, for example. And you can make yet another interface for the three-dimensional things. So a rectangle, you could have, this could be cube, and so you could actually have an interface for these guys that's separate. That could be a three-dimensional interface that specifically says that all of these have a method called get volume, and that all of these have something that's called get area. So you could make interfaces for all 3 of these and a separate interface for all 3 of these. Yeah. Okie dokie. So yeah, that's And that's a lot. Like if all of this is looking pretty comfortable, then you're pretty much golden for the rest of the semester and most way through next semester of programming. So
Okay.
yeah. So if any of this is like intimidating or anything, that's fine. That's totally to be expected because this is some pretty crazy and wild stuff.
Yeah, just a little bit.
Yeah. But this is like so essentially just keep like staring at this, and if you have questions, let me know because this is super key.
Okay.
Um, all right. I don't know. Did you want to do? So we've got 15 minutes, right? Yeah, we've got 15 minutes. Did you want me to do the a circle or sphere, or did you have questions about something?
I don't have any specific questions, but maybe if I see you do a circle or a sphere, maybe it'll come together more.
Okay. So let's do that. So we've got our line and we've got our point. Come on, terminal. Okay, there we go. Okay. So we're going to say nano, and I need to spell circle right. Okay. So we have this guy. Oh, whoops, I need to actually call it the right thing. There we go. Sorry. C-I-R-C-O. Okay. Okay. So here we're going to have a point. We're going to call them center. And then we're going to have a line. We're going to call radius, radii. Radius. Okay. All right. Okay. So we're going to make our constructor. Let's see. So our default one is just going to create our center is going to equal a new point, and then our radius is going to equal a new line. And so what we could do is for an overloaded constructor, we could take in a double as the center X and center Y, and then radius. Or maybe they give us a double that's the edge. And then we have to then figure out those details. So, oh, and then let's just quickly write these guys. And so here we could call the toString for the line and the toString for the center. So let's say center, we can say centered at, and then we can say radius of, and then that's going to be radius dot get length, and we don't need that guy. So here we're not, in this toString, we're not at all revealing how our internal structure is working. That we're saying radius of, but they don't know that we're using a line. This could be a double, that we could be keeping track of the radius as double for all I know, but they don't, whoever's using our class doesn't need to know that. And so that's part of that abstraction. So yeah, we could be using a double here, but we're using a line instead. And whoever's using our class has no way of knowing that. And that's good, because that means that if later on we decide, no, it's much easier, instead of having to do this get length all the time, let's just store it as a double and call it good. And it really depends on how we're using it too.
In your point.java, I think, did it have two X and Y, or like X and Y variables?
Yeah.
So yes, that one. Or wait.
No, let's 1 second. Exit, and then if I could spell. There we go.
Yeah, so in the circle one, do we not have to have like two variables to represent the X and Y?
Oh, so
or maybe I'm getting confused.
Yeah, so for the center we do, right? We have our X and Y, and then maybe this is just the, so here we could say edge X and edge Y. We could do that.
Okay.
So we're gonna make, so our line is gonna contain our center as well.
Okay.
So yeah, so I guess let's do that. So let's make a point. So we're gonna say center equals point, and then we're gonna feed it in the center X and center Y. And then we didn't write this, but this was in the comment of the to-do, is that for the line, maybe line can take in as a constructor radius. It could take in 2 points as a constructor, and so we can jump back into line and we could write that real quick. So we would say new point of edge X. So yeah, let's hop over and do that real quick. So let's do that. Okay, so I just wrote that constructor that we're going to be using, which is right here.
Okay.
So now we can feed in, here's a point, and here's a point. Oh, and I need to fix that there. So here's a point and here's a point, and so we're using this constructor here for line. So now radius is of line. All right. And then, so center, toString, and then we're just going to call our own toString, and then there we go. Let's
Okay.
make sure that that compiles. At some point, I should write an ant script. Oh, did I type an integer somewhere? Points lossy edge x edge y. Oh, whoops, I forgot the word. Okay. New. Okay. Okay. And now from double to int. So let's take a look here. Those are okay. These need to be double. See, that's where all my trouble's been coming from. Okay. All right. Now let's do it. Okay, cool. Looks good. All right. So there we go. So there's our point and there's our circle. And we got 2 minutes. Any questions?
No, not right now. Thanks for doing that.
Yeah. So and I'll throw this up on the GitHub if you need to reference it too.
Okay. Thanks, Carter.
All right. See you in class.
See you there.